Hello class, this is a video tutorial on negative numbers raised by powers or raised with an index. So recall that indices are a way to represent repeated multiplication. So before we continue, let's do a quick recall for here. So let's express the following in expanded notation and then evaluate them. So 2 to the power of 4, what is that in expanded notation? And then what is the answer to that if you were to calculate it or type it into a calculator. I'm going to show these, the answers to these in 3, 2, 1. All right. Check your answers and see how we go. Because now what I'd like for us to learn is that indices also take into account negative numbers when repeating multiplication. You will have to recall the rules for multiplying negative numbers. So pay attention whenever we input negative numbers with indices into a calculator. I'll demonstrate to you what I mean when we get there. So let's express the following in expanded notation and then evaluate it. So what this means is that whenever we have, let's say, negative 2 to the power of 6, or a negative number to the power of something, it still takes into account that it's going to be negative 2 times negative 2, well, 6 times in this instance. So this is 3, that's 5, 1, 2, 3, 4, 5, and 6. So the negative doesn't suddenly vanish. It repeats the negative as well as the base, however many times the index shows. Okay, so with that in mind now, we can simply multiply. Now, I'm going to do this in a rather special way because it'll emphasize something a little bit later and it makes it easier. So in this case, let's pair them up. What's negative 2 times negative 2? Well, that will give us positive 4. So that's the first pair. Let's do it now for this pair here. Negative 2 times negative 2, that's also 4. And this multiplication stays where it is. Notice what's happening here. I'm pairing them up. And it will happen to this last pair here. This will give us a positive 4 because two negatives make a positive. And now this is a lot easier. 4 times 4 is 16. 16 times 4 is going to be 64. And that there is 2 to the power of 6. Well, negative 2, sorry, to the power of 6. Alright, so I want you to try it again for the next 3. You can, well, I'm going to pause. You can write all of them in expanded notation first. I'm going to show this in 3, 2, 1. All right, there we go. I hope you can see that it takes into account the negative indices as well. And likewise, if you'd like to pause and evaluate these yourselves, I want you to do the little method that I did where we paired them up to make it a lot easier. So I'll demonstrate this now as we go through these answers. Negative 3 times negative 3, that will give us positive 9. That multiplication stays where it is. And now this pair will multiply. Negative 3 times negative 3. That will also give us positive 9. And that will give us 81. Alright, so let's keep going here. Now, I hope you can see something interesting that will happen. When we try and do the pair method, we're trying to pair these up. So negative 4 times negative 4, that's going to give us positive 16. But now notice how with this one, it doesn't have a pair, so it must stay as, well, 16. In this case, stay as a negative 4. In this case, we know that these two become 16, which is what we have here. But now we're going to multiply by 4, like we did in this one. However, it's negative 4. So this will give us negative 64, because a positive and negative multiplying give us a negative answer. Okay, so another one here. So 5 times 5, well, negative 5 times negative 5 gives us positive 25. And this we're going to multiply by a negative 5. In this case, it'll give us negative 125. All right. So I hope you can see some sort of pattern happening here. Why is it the case that these are positive answers, whereas these ones are negative answers? Okay, so let's take a look and let's expand on this problem a little further. So let's look at odd and even indices. So without using a calculator, determine whether the answer is going to be positive or negative. So these two, let's figure out whether it's positive or negative. I don't care what the actual answer is. If all we're looking for is whether this answer is going to be positive some number, or this one's going to be negative of some number, or they might both be positive or they might both be negative. We don't know. Okay, to help us answer this, let's recall that two negative numbers multiplying will equal a positive answer. Using this idea, we can see that even indices will have a positive result and odd indices will have a negative result. We can see that here. Negative 2 to the power of 6, that's an even number. Notice how we get a positive answer. Likewise with this one. 4 is an even number. Negative 3 to the power of a even number gives us a positive 81. And the reverse is true. If we have odd numbers like this, so negative number raised by an odd power, we get negative answers. So it's rather straightforward if we just follow that rule. So in this case, this is a negative number raised by 100. 100 is an even number. So the answer to this will be a positive. And this one, a negative 2 to the power of 101. 101 is an odd number. So this will give us a negative answer. But let's explore why this might be true. So let's first write all of these in expanded notation. You can pause and give this a go yourself. Well, we've already done these. So negative 2 times, negative 2, there's 4 times. Now if we were to do this for the next one, where it's 5 times, well, it's rather straightforward. We have, there's 4 times, let's do it one more time. There we are. And for these ones, there's 5 times, we just need 6 times, so let's add one more. There's 6 times. And for this one, let's do it for 7 times. That's 6. Let's include one more. Now let's go back to what I demonstrated where we pair these numbers up. Let's not worry too much about the answers to these. Let's just take a look at what happens when we try and pair these up. So taking a look, once these two are paired, it will give us a positive answer. Once these two are paired, this will give us a positive answer. And a positive times a positive times a positive, well, that will give us a positive answer. Now let's take a look at what happens when we try and pair these up. So we have a pair here, a pair here, but this one will be on its own. So these two, this will become a positive times a positive. These two will become positive answers. But now take a look. This negative 2 multiplying will keep following, and there will always be a negative answer at the end. So this will give us a negative answer. Likewise with this, if we try and pair these up, notice how this is an even indice. There's 1 pair, 2 pair, 3 pair. Notice how all of these negative numbers are being paired. So this will be a positive times a positive times a positive. These are all just positive answers now. So the final answer to this must also be positive. And likewise with this one, same thing, if we try and pair them up. These three will now become positives, like what we saw here. However, this -2, which doesn't have a pair, will make the final answer just all negative. Okay, so I hope you can see now why it's the case that even indices will have positive results and odd indices will give negative results with a negative base. Alright, so I hope that gave you an insight into negative numbers raised by powers. Hope to see you in the next video, and best of luck.